Hi, I'm Vasily, the host of the Daily Recall Show. Today, I will explain how to think in systems. And I will actually do that in real time for the topic that I don't really know much about. So you'll get to see if I'm any good at this process, and you will get to understand the process really well, because I will not be dumping at you some theory and stuff, but you will just get to see how it works in the real world. And the process that I will be explaining is called the thought development process. Let's kick it off. So let's suppose that we've got some idea that we want to develop. And for the purpose of this demo, let's take something like writing a work or writing a thesis on a subject of World War II, right? So let's say that we've got some vague understanding of World War II, because I'm not actually a history expert, and what we want to do is to develop the thought even further, to flesh it out, to come up with an insight probably for this specific idea, something like that. And the tools that I'm going to be using today are actually really great and efficient thinking tools. It's called paper and a pen. Okay, now I'll explain why I picked these tools specifically for the purpose of this problem, but let's just get into it and then we'll see how it goes. So to begin with, let me actually outline how not to do this, okay? Because I think that negative advice is actually really good. So if you know how not to do this, then you'll naturally arrive to a place where you get to do things in a much more convenient and better way. So let's say how most people actually approach this problem is that they start thinking about the subject of their work or something like that, right? When you get a task at the university or college to write an essay on the World War II, they tell you to pick the subject, and that's a really dumb idea. I don't know why they do that, because the subject actually is a compressed essence of the work. And how can you possibly pick the subject before you've actually thought about the work at all? That's a really dumb idea, right? But they somewhat still do that. So the regular kind of student approach to thinking about this thing would be that, okay, I gotta pick a subject, then I pick some subject, then I probably have to write some bullet points on that, to outline the structure of the work, right? That's how you do that. That's how you write your thesis, diploma. And then I gotta research stuff, right? But that's actually how not to do that, because first, you cannot really come up with a great subject by doing that, because subject is a proxy of the insight that you've got by writing the work, and you don't have any insight yet. And second, you cannot possibly impose artificial structure on the thought. So that's just an example. The second way that people usually do this problem is they start brainstorming around. They're like, oh, I'm gonna brainstorm, I'm gonna write a bunch of things down and see if anything sticks, right? And that's really dumb idea as well. Brainstorming is good because it lets you bypass your filters that actually kind of take their craziest ideas, which have the germ of becoming really good ones, away. But brainstorming is very limited to in comparison to what I'm going to show you. It's like a good metaphor would be that there was this man flight idea, that a man could fly, right? And the first actually realization of that idea was the aerostat, the balloon. And brainstorming for thinking is like aerostat for man flight. It's a proof that we can actually augment the thinking process, but it's very limited, right? Because this thing, it cannot fly really fast. You cannot really control where you fly, where the wind goes. That's how you do that, right? Then the balloon can easily break and then you fall. So there are different problems with that. And the system that I'm going to show you, the thought development process, it's more like a jet fighter, something like that. Like the F of any model, the United States jet fighter, which is great and which can fly supersonic and do all those things. So that's just to keep in mind why brainstorming is good and why it's bad. The reason why it's bad is because any idea that you brainstorm, you have no criteria for actually sorting them. How do you actually do that? So, and why do you need many ideas if you can just know how to solve the problem? So that's why brainstorming is not the right approach. But how are we going to do this? We've got a list, we've got a piece of paper, and first let's just start by outlining what we're after here, right? So I don't have actually any idea what we're going to get, and that is good, because if you know what you're going to get out of this means that you've already known that. You don't have to develop any insight at all, right? So any research is when you're not exactly sure what you're doing. And we're going to start by just writing down the thing as it is, right? So that's what we're like gonna think towards, right? We want to expand this idea, we want to develop this idea, we want to find out any insight about this idea. Let's go. So the first thing that I would do is to just think proactively if I have anything that might be relevant to this World War II idea, okay? And just like write it down. So that's a very, very, very simple and very quick process. You don't have like write down many different things and use like a wall or something like that for doing this. So I'll just go ahead and write down what I remember about the World War II. And the thing is that I remember that there were like these Soviet Union guys, because I'm from the post-Soviet Union country. There was the Soviet Union, they were United States, then there were like these Nazi guys, of course, there were like some Japanese guys, there was this very popular tank model, which is T-34, which they fought for Berlin. Let's actually write that down as well. And then yeah, there were like this Italian guys who actually joined the Nazi, something like that. Then it was like 1945 when the war ended, and then 41 when it began, right? So that's actually it for now. I think we can go on with this. It will be enough to show you the idea and the thought process, and then you can actually use the process to extend this further or to apply it to any problem that you want to think of. Okay, so the first idea, the first kind of big part of the process that I'm using here is called spatial interface. Spatial interface means that we do not do this thought process in a like linear sequential way, which is a text, right? So you've got like a notebook or something and with lines, or a page on your computer screen in the Word or in the word processor. When you like type there or write there, you basically just follow the rules. You start from the left top corner and then you kind of like go down, right? So that's actually not very good for thinking, and I'm going to show you why. So the first thing that we need to do is to take a spatial interface, which might be their piece of paper, just a piece of paper. And then we can do like any like large one, we can pick a whiteboard or something, but a piece of paper will suffice for now. So let's just look at this and see if there is anything interesting just from this first like from this first outlining. Okay, so from the system standpoint, this is the second big cluster. From the system standpoint, what we actually did right now is we went from a monosystem to a polysystem with zero connectivity. Well, what does that mean? So if you watched my video on the mono to poly transformation, I actually explained how to do that for a pack of pencil. And if you don't remember that, let's just bring it up real quick. So a pencil is a monosystem because it's like used out its resources for development, and it just does its own function, right? You can draw with a pencil. And if we want to like improve the system and improve the function which the system is performing, which is drawing, we can take this system through a transformation called mono-poly. So we do our homogeneous polysystem, which means that we just put a bunch of pencils together in a pack. So we've got like a pack of 10 pencil, okay? And that's actually really good because a pack of 10 pencil is better than a pack of 1. You can collaborate, you can have one more if you break it and stuff like that. So that's step 1, a homogeneous or mono to poly transformation. Then we can shift the parameters of the pencil. And the way to increase the efficiency of the system, of the newly merged polysystem, is by changing and improving the diversity of its elements, okay? And in the pack example, we did that by just saying that, okay, we've got like 10 pencils in this pack, but they're all the same. But what if we do multicolor? That would be great because you could do so much more, right? By having just 10 our most popular colors, you can draw many different things. Instead of just having like black, all of them black. So by increasing the diversity of those monosystems, which the polysystem is comprised of, we've got a homogeneous polysystem with shifted parameters. That's step 2. Step 3 would be to do from homo to hetero, do the object type transformation, where basically a heterogeneous polysystem with shifted parameters is a pack of multicolor pencil with some other object that augments the function of drawing, which might be a compass or a ruler, right? So we added new objects to the system. And then the final transformation would be to do their inverse characteristics transformation, which means that if the function is drawing, then the inverse function is erasing, and then we can have an eraser over there in this pack of pencil, and that's how we get to perform the function better, the drawing function, right? That's just a quick recap. And the cool idea about this transformation is that a thought that we're developing, it's actually a system. So I want just to repeat that for this idea to kind of sink in your head. A thought that we are developing is actually a system, okay? And what we did now, when I first wrote this down, World War II, simple thing, that was just a monosystem. It was just one idea in my head, right? But we actually did the first transformation right now, and you probably haven't noticed that. We went from a monosystem to a polysystem, or a homogeneous polysystem. Okay, and it's called our zero connectivity system because those elements are not connected any much together. But let's actually think from the spatial perspective. I can easily, by looking at this piece of paper with these like monosystems that are individual and outlined over there, I can see easily that those like Japanese Nazi guys and Italian guys, they were actually the bad guys in the war, right? And on the opposite side, I can see that like there was Soviet Union and there was United States, and they were actually the good guys. So that's a really interesting insight. So let's write that down. And what we did now is we kind of like leveled up a little bit, right? We understood that those individual components, they combine into another system, into another representation, okay? So I'm gonna just write this down real quick. Good guys over there. And then we've got 2 arrows, right? So we've got good guys, like in Soviet Union and United States, and let's actually do this for the bad guys as well. So for the bad guys, we've got Japanese, we've got Nazi, we've got Italian guys, right? And yeah, let's just underline them so that you get to see this more clearly. So what we did now is that we used one of the features of the spatial interface for thought, which helped us to understand that, okay? And the idea is that when you outline things, when you outline individual thoughts in a spatial interface, you actually get to see connections between them, and not only between our one-to-one, not only one-to-one connections, but one-to-many connections and individual interconnections as well. So it's really impossible to do that in a sequential interface. And this group relations thing is just does wonders. But then if I think about this even further, the second characteristic of a spatial interface pops up, which is called the imprecise location. Okay, and if you take a look at this, you can see that we've got Japanese, we've got Nazi, we've got Italian guys, and they're all bad guys. And then you can see that there is like some space over here, right? And there are like 3 arrows that go from bad guys to like those elements from which the bad guys system is comprised of. And then immediately, like in my head, I start thinking that, like, could it be the case that there were more bad guys? So this is really interesting, right? Because here, the space, the empty space that's right there below the bad guys, actually helped me to identify a possibility that there might be another element to this cluster. So this is called the spatial location thing, and and that's how I get to understand that, right? And I immediately see that for the good guys, I'm like, wow, those United Kingdom which fought in Africa, right? And or those France, and so those were like good guys. So let's add them over there. So that's how we did the first like our ideation phase, right? And United Kingdom, and let's write down Africa over there. Maybe we'll stumble upon something that might be relevant. So this is, you can go on like this forever. You can look for these individual relations. But an interesting thing is that another property of the spatial interface is that when you look at this, you can see that any element here might be connected to any other element. And the relation of those elements is actually a new knowledge type. Okay, so before that, when we just had like this World War II, it was just one unit, one monosystem. Now we have a homogeneous polysystem. Homogeneous because those are individual ideas, right? A polysystem because it's like a big kind of like not clear really system of many monosystems put together, like with zero connectivity. There is some over there. So that's cool. We've done the first step, right? And there are 2 different things from spatial interface that actually helped us to do this. The first is this idea that if there is space here, then there might be something else. So it kind of like has high suggestive value for developing the thought further. And then the second idea was that we actually could see the relations between those 2 objects, and we could see, okay, and if we just think about this Soviet Union and Japanese guys, what actually happened there? So that's another thought, right? That's another idea right there. So, but that's just first step. Let's move on and develop our thought even further through the thought development process. And the second step of the thought development process would be to take the system from having individual parameters to having shifted parameters. So again, we increase the efficiency of the newly merged polysystem by making the individual elements more diverse. Or in the example with a pack of pencil, that was going from a pack of just black pencil, the cool ones, to multicolor, right? So we increased the diversity of individual elements and the whole system became much better. So we can draw much more interesting stuff with our multicolor pencils. And here, the interesting idea would be that there are these like all knowledge representations, right? So all individual monosystems. And that's actually not knowledge, what is here. That's a representation of knowledge that is in your head, okay? And it's a very important idea to understand that. So whenever you write something down, whenever you read a book, whenever you whenever you see something that you think is knowledge, it's not actually knowledge. It's a representation of knowledge in the world. And the real knowledge is in your head, okay? And that means that there might be different representations besides the factual one, which is what we have over here. So we have that like the bad guys and the good guys, and there was some interaction between them, there was some struggle, and we can identify some individual relations as well. But each of those knowledge units, the good guys, the United States, the Japanese, can be represented from a different dimension. And that dimension is questions. So questions are really magnificent things. And you've probably heard that a million times. You got to ask the right question, right? But they never told you why. And the reason why questions are so good is because questions are a different way to represent knowledge. So let's just do this transformation thing, and we'll see if we stumble upon something really interesting. So whenever we see the knowledge unit or representation over there, like the bad guys, I can try to, what I can do now during this step 2 in our thought development process, I can actually try thinking of a question where the bad guys would be the answer. That's how we do the enrichment phase, okay? That's how we add more knowledge over there. So that's a very interesting idea, because if you just think of factual knowledge as is, it's really hard for you to actually pull that knowledge from your brain. And people do like this brainstorming, brain dumping stuff to do that, but a much better way is to start asking questions. So let's think of a couple questions that might actually help us to extend and enrich this department of bad guys that we've got over there. And one idea would be that we can come up with questions where the bad guys is the answer, right? And let's just think for a second. Let me think for a second. The first question that they came up with was, who actually started the World War II? The bad guys, right? The second one would be, I know a good deal about Richard Hamming, or about Hamming and Feynman, and all great minds of the 20th century. So they actually worked on the atomic bomb in Los Alamos in 1945. And then the question that I can ask based on that knowledge is, okay, but who were the guys that actually made the United States to put up a team at Los Alamos to do the atomic bomb? The bad guys. Who were the guys who were ruining the London with those bombers that flew and killed so many people? The bad guys. Who were the guys that came to like invade Russia real quick with their blitzkrieg operation and almost won the war in 1941? The bad guys. Who were the guys who killed so many people and so many like innocent people in villages? The bad guys, right? So you can follow this process forever, literally, because you can come up with questions. And I'm not going to write them down here because I'm running out of space, but you can pick another piece of paper or whatever that suits your purpose, and you can do that for each knowledge unit. So you can think of this as like growing in a fractal manner. So you start from like a very single idea, which you have like really, what you really like know nothing about, right? It seems to you that you know nothing about it. At least that was my original idea when I thought of this World War II thing. But then we can start thinking of so many different interesting ideas following the thought development process. So that's step 2. We shifted the parameters and we kind of invoked this another dimension of knowledge, which is questions. And we used the factual knowledge that we've got over there, the bad guys, to present it as an answer to the questions that we come up with. So that's what we've done. That's the step 2. The step 3 to the process would be to go from a homogeneous system, homogeneous polysystem with shifted parameters, to heterogeneous polysystem with shifted parameters. What does that mean? In the pencil pack example, that was basically when we added new objects that performed kind of a little bit different function than the original ones, okay? And in the thought development process, that means going beyond the text, okay? So now we actually only have symbolic representation of knowledge over there. Symbolic, I mean, we've got words, right? And some numbers as well, like 1945. But then what would be another object that can help us perform the function, which is to develop our thought, to flesh out our thought over there about the World War II? What would be the other like type of object that could help us do that? And the obvious answer is media, right? So we can literally like go and print some like T-34 tank images, Berlin stuff, like I don't know, United States, something related to the United States. So by having this another dimension, which is image, right? Just visual. It could be image, it could be video, it could be audio. You can extend this as much as you want. You can start having new thoughts. Okay, so that's the step 3. Or again, in the pencil pack example, it was basically adding another object to the pack besides the pencils that were there. And here it's adding new knowledge types, new representations of knowledge, which here we've got text, then the new ones would be media. Okay, and the 4th step of the thought development process is called to invert the characteristics of a system. So we can think of it as 2 ways. As almost there are like 2 dimensions in the world. So there is the positive knowledge and the negative knowledge. And positive and negative means not in the sense that it's like good or bad, but there is knowledge that is factual, right? Or positive in the sense that this is a thing, this is a tree, right? And there is an inverted representation of that knowledge, which is there is no tree. So that's the opposite, right? And the opposite can go either from the object or from the function. That's important to understand. So let me just quickly glance through the list that we've got over there and see if we can transform each of those individual elements somehow so that we get to do this inversion, right? And the thing that catch my mind was like the T-34 tank, okay? And let's see, like the function of the tank, of this war machine that was like crushing bones and going through soldiers, was to attack, right? That's what like the bad guys, the Nazi guys used tanks for in the First World War and the Second World War as well. So the function of the tank is the attack function, right? To crush through those armies of soldiers. But then we can think of the function, and then we can like say, okay, and what would the opposite function be? The defense, right? And then I start thinking, okay, but like let's just invert this tank. What's on the other side? And it might be, from their object standpoint, might be no tank, and then I can start thinking, how did those tanks were actually created, right, in the first place? That's another line of thought that we can follow. And the more interesting one to me is to have an anti-object to a tank. So if a tank is an attack device, an offense device, then what would be a defense device? That's like a bazooka that you strike the tank with, right? And those guys actually, the T-34 tanks, they suffered that much from German bazookas when they were sieging the Berlin in 1944, 1945. So that's how we can like flip this, and we can see that so I'm just going to add an image over there just to like give you an example of the process. And we can see that if a tank is positive, then a negative would be bazooka. Right. So I just did that real quick with plus and minus signs to give you a visual idea of how the inversion works. Another example of inversion, so that you get to sink that idea in your head really clear, is what I call the greenhouse effect. So for example, we can have a really efficient greenhouse if we put half the plants that produce oxygen and half the plants that that consume oxygen, right? That would be a great greenhouse because those two would auto-catalyze each other and contribute to the whole system. So like the diversity of individual components of a system actually improves the system's efficiency a lot. Another example would be the pencil pack transformation that we used, right? So if you add an eraser, that's a much better pack of pencils, because you can draw and you can erase and you can draw better pictures with that. And some pictures, like those architecture designs, they cannot actually be possibly drawn without an eraser. So that's how you augment the function by a lot, right? So we've got some really good stuff here in just like 10-15 minutes. But let's see what else we can do over there. So we did all these transformations for a couple object types. So just to give you an idea, you can follow this process for an hour and you will get much more out of it, even out of your present knowledge. That's the best thing. The thinking comes from what you already know, not from what you like go and Google and just copy to your work or something. the thinking, the real insight comes from the knowledge that you have, not that from the knowledge, from the information that you get out of the world. Okay? And another idea how I would be solving this problem would be to use their 3 tree screens metaphor. So that's a video right there. Go ahead and watch it if you haven't seen it. But basically, it actually allows us to add a time dimension and a complexity dimension over there. Okay, and then we can take like one element of here. Let's just take Japanese guys. And let's think through the time dimension for Japanese guys over there. What would, like, how they actually evolved as a part of the whole system during the World War II. And then we can go back in time and we can ask, okay, but how did actually, the really interesting question that I've just come up with is, how did actually Japanese come to be Nazi guys? I don't know. But that's a really interesting question. I'm going to look that up after I finish recording this. So you can do the same thing for like Italian guys. We can write like the biggest bad guy here, the Hitler guy, or you can go ahead and look it up, like how Hitler came to be a Nazist. So that's really interesting, right? And that's just the past. And then we can start looking, okay, but what actually happened to, say, Germany after the World War II? What did happen to them? What was the story? How the things evolved? So that's how you can really like start thinking about these things. And this time dimension that you add brings enormous amount of information and knowledge and insight, because again, all those things interact with each other, or you can start seeing clusters, right? You can start seeing relations between clusters, and that's the final step. So once you do this enrichment for quite some time, you'll start seeing the forest behind the trees, okay? And that the very tiny example of that is the bad guys and the good guys clusters that we've got over there in just a few minutes, okay? But once you do the enrichment, once you add more knowledge here, once you start defining those relations, asking questions, creating media and questions representations, all those things, you will start seeing more and more relations. You will form more and more clusters towards this idea. You will develop the thought progressively forward. And then basically what happens next is you will level up, right? So you will have that system that you have developed and understood well will basically compress from being a polysystem of having like many different individual elements, right, to being a newly formed monosystem, okay? So, and you just now, you went from operating on a very low level of information, or you don't have to decide actually, you don't get to decide. You just start anywhere you are in the process with what you got in your head. But then you progressively level up. Okay, so once you develop the cluster, it becomes like a new monosystem instead. And then you can start asking more interesting questions. And what's the bigger system is about, right? So what is the big system? If this was a book about bad guys and good guys, what would be the book about? So that's one way of thinking about this. You can go through these tiers, and they can be like multidimensional as well. You can play the whole system forward or back in time. You can do all those things. So just to recap, we went through the 4 stages of transforming our vague idea of World War II to something really interesting and a well fleshed out thought that we can use to do whatever we want with it, whatever was our original aim. If that was to write a thesis, then we can easily, just by doing this for 10-15 minutes, we came up with so many interesting questions. And if you remember that idea from 10 minutes ago, that a question is just another representation of the factual knowledge. If there is a question, then there is an answer, right? Then you can figure out that for those questions that we've come up with, the answer might actually be the insight that will basically drive your work forward, drive your work towards the goal that you have actually outlined for yourself in the past. So this final stage, when those systems start compressing and becoming new monosystems, and then you put them together, and then you do the transformation. That's how you get to like, you can think of it this way. You can get to go like from this 2D to a 3D image, and you start thinking in new different models.